Soap is everywhere. We use it every day to wash our hands, do our laundry, and clean our dishes. But what exactly is soap, and how does it work? Turns out the chemistry behind soap is actually pretty cool. Before I get into exactly what soap is, I'm going to start with how you make it. It's actually pretty simple. First, you start with some oils, typically a combination of oils that are solid at room temperature, like coconut oil, and oils that are liquid at room temperature, like olive oil. Then you'll need a strong base, typically sodium hydroxide, also known as lye. Heat the oils and the sodium hydroxide, and then when they're about the same temperature, mix them together and keep the mixture warm until it thickens, like pudding. Then pour it into a mold, wait for it to cure for a couple months, and bam, you've got soap. Getting the ratios and temperature right is important, so don't try to use this video as a soap making instructions. The process of using a strong base to turn oils, or triglycerides, into soap is called a base-promoted ester hydrolysis reaction, or more commonly, saponification. The resulting product is a ton of soap molecules, which look like this. On this end is a super long chain of carbon and hydrogen atoms called a fatty acid. This tail is nonpolar, meaning it doesn't have much of an electric charge, so it's great at dissolving with other nonpolar substances like grease and oil. However, for that same reason, it's also hydrophobic, meaning it won't dissolve in water. That's where the head of this molecule comes in. Reacting with sodium hydroxide left the head of this molecule with a pretty strong negative charge, making it polar. That means the head of this molecule is great at dissolving with other polar substances, like, you guessed it, water. This soap molecule having one hydrophilic end and one hydrophobic end is exactly what makes it so great at cleaning stuff. The hydrophobic tail of the soap molecule bonds with the lipid barriers that protect some bacteria and viruses. The fatty acid tails puncture the lipid membrane and water rushes in, killing the microbe. As more and more fatty acid tails surround what's left of the microbe, it forms what's called a micelle. Micelles also attack bits of dirt and grime, and when you rinse off the soap with water, the polar exterior of the micelle allows everything to be washed away, leaving you with clean hands or dishes or clothes. Since soap molecules can dissolve water and oil while killing harmful viruses and bacteria, it's no wonder chemists think it's suds a great invention.